Hi, this is Jishan Mukha, and today we are here to discuss about the servOS kernel, a special purpose operating system kernel for server machines. We'll talk about the what is servOS kernel and what is where it is used and what is the function of the servOS kernel. Okay. Now, what is a kernel? Generally, first we'll talk about what is does a kernel and what does it will do in the system. Yeah. Now, yeah, kernel is a central component of an operating system that manages operation of computer and hardware. It basically manages operations of memory and CPU time. It is a core component of operating system. Kernel acts as a bridge between applications and data processing performed at a hardware level using inter-process communication and system calls. Yeah. Now, kernel loads first into memory when an operating system is loaded and remains into memory until operating system is shut down again. It is responsible for various tasks such as disk management, task management, and memory management. Now, it decides which process should be allocated to processor to execute and which process should be kept in the main memory to execute next after that main process is occurred. Now, it basically acts as an interface between user applicants and hardware. The major aim of kernel is to manage communication between software, i.e., user level applications, and a hardware, computer disk, and memory. That's it. Now, introduction. What is so yeah, let's go for introduction of this topic. A distributed computer system that is modeled after workstation servers model SV Svobodova. Okay, that's a difficult name. Svobodova L51 contains two disjoint classes of machines: user machines for human users and server machines offering services to the user machines. For the server machines, this paper poses the question of appropriate OS support for these server modules, which provides the services. The proposed solution is based on the following basic requirements. Means these are the requirements through which the server will be worked accordingly. First thing, free configurability, low level of server module services, low level of OS support. Okay. Now we will see the architecture, the basic architecture, how the servers will be. Means serve OS. See, here the client will be means here the client or the user will give the information to server module and the communicationable subsystem of arbitrary machine. And this arbitrary machine will send the data to communication subsystem of server machine, as well as the server module will also be connected with the server module and the communication subsystem. Now, this communication subsystem is connected to server module manager, which manages the instructions, and whole this server machine is called the kernel, which is called servOS, which is connected to the base system communication subsystem, which is called base machine. Here it contains three machines, which is arbitrary machine, server machine, and a base machine. Through this, the communication, the process of executing information or getting input and output is occurred. Now, see the server module model. The server module model describes the common characteristics of all server modules. That the aspects addressed are the internal structure of server modules, the protocols between clients and servers modules, and the base and the kernel operations on server modules. Closely related to this module is the support kernels provide to their server modules. Okay. Now, the areas covered by this section are server module states, client server protocols, protection, processing, and address spaces, communications, input, output, and the signals. Signals in the sense sending of the data and retrieving of the data. Now, protection. Here the main concept comes the function of kernel, servOS. Why servOS is very important? Because the problem to be solved within the the client server protocols is protection. Means the protection is the priority with highest priority. So in servOS kernel, server modules use amoeba style capabilities in an extended way, especially tailored to server module model. Besides amoeba's object capabilities, in servOS, there are three more classes of capabilities. A connection capability is created by server module during its execution of an open operation and protects the following operation calls of this connection. Now, an operation that cannot be conceived as an operation or an already existing object. Example, the creation option. The create option is protected by a special capability, the create capability, and a server module uses another capability, the administration capability for administration operations, which offers to the system administrator. Means it completely related to the administration part. And in a general purpose OS, there is also a protection problem at the system call interface. One may wish to restrict the right of user purpose processes to call certain system calls or system calls on the certain objects. In contrast, on server machine, there are only trusted components, in particular, no user processes. Therefore, there is no need of protecting system calls. That's the reason why we don't even protect the system calls in the interface. Now, the processes and the address spaces. Yeah. Compared with other user programs, server modules more heavily demand for parallel execution. Example, operations. Therefore, a server module internally consists of parallel processors with partially shared address spaces. These processes can synchronize using semaphores, which are managed by kernel. Now, the process structure is dynamic, which means that with one exception, there is created and destroyed on extra process for any operation call. The exception is for connections where one process executes all operations calls from open to close. Here, the process can preserve in its address space state information across operation calls. Example, the key for the connection capability, all processors are managed by the kernel. Now, how does the communication process occurs in the servos kernel? See, server modules need communication support for operation calls only. Another communication pattern, the pipeline frequently occurs on user machines, but not on server machines. The communication subsystems provide their operation call support at very high level, partially closer to programming language procedures calls than was previously known. For the client, there is a primitive server call which performs an operation call with at most once semantic. Locating the server is done transparently within server OP call. The server module's location is derived from its name, which is part of capability contained in the request. Requests and responses may be arbitrarily long. Okay. Yeah. How does the input and output process occurs through this servOS kernel? See, those server modules that manages devices contain device drivers. The drivers need special support for the communication with the device controllers. Usually, communication is done via device registers via shared memory areas and by interrupt signals. Okay. In servOS device registers can be mapped into a server's module's virtual address space. A system called heap map register allocates pages on the heap, yields the virtual address of this area, and maps it onto the physical area starting at page page on. Okay. Device controllers usually access memory areas indicating physical addresses. Therefore, such areas must be physically contiguous and must not be relocated in physical memory. For this purpose, there is a special system called heap get config pages, which allocates an heap area with these attributes and returns a virtual as well as a physical address. Okay. Now, what are the signals and how does the signals will be shared from one part to another part in this system? Now, on a server machine, there need not to be any support for those signals that arise only on the user machines. Example, those that are invoked by users keystrokes. On the other hand, the servos kernel supports signals that are of no relevance low to user programs. One example is that mentioned device interrupt signal. Two more examples are forced closely and kernel operation. See, generally, the signals which does not require any support from kernel is, so example, if we want to give any input from the user, then we just go on to type on the keyboard. But we generally it does not require any external support from the kernel or any other system to get the input from the user. Since a direct program, we just press S, then it will be automatically get S. That's it. That's a simple. And we'll go for conclusion. We got to know the problem of the appropriate OS support to server modules loaded on the server machines. It proposed a special purpose OS kernel, the servOS kernel, which gives special support to server modules that conform to the server module model. The article showed, means the article in the sense the whole PPT we have showed various aspects where servers reaches two advantages over its main competitors. General purpose is device kernels exploiting simpler problems by simpler solutions and giving higher level support to the server modules. Okay. And a simpler solution was applied to the memory management problem, omitting secondary storage for server machines. Also, the protection measures for the system calls were found to be superfluous. Communication support is needed only for one communication pattern for operation calls, and some user machine signals don't arise on server machines. Okay. We define a fine-grained model for server modules, including their stage, classification of server operations, signal handlers, capabilities, and server processes, and the relationships among them. This knowledge allows the kernels to give the desired special support. They provide a higher level communication interface, special signal types, special address space structure, special support to the device drivers, and special management operations for server modules. This is the main content, and I think you got an idea about what does a servos kernel is and what does the module do, and how does it help us in performing some security patches or any other thing. Okay, thank you.